So if you've never heard of the Nike Vaporfly shoes, they're these shoes that marathoners are wearing to hopefully decrease their marathon time. And people have said that it's so effective that they've even thought about banning them. Luckily, they didn't do that at this point, as you can see from this headline. But the question is, do these shoes really make a big difference in how well a person can run a marathon? So that's the question that we're looking at here. We have 6 elite marathon runners where we were actually able to measure their times running the New York Marathon, once without the Vaporfly shoes and then again with the Vaporfly shoes. And we want to see, did it help to increase their time? Do we have enough evidence to say that? And so in this case, we're going to be looking for that strong evidence and testing it at a zero point 0.01 level of significance. So before we get started, let's think about the type of test we're going to be using, which again is step 2, but it helps to think about this first. What we see is that we have 2 sets of data, right? Once without the shoes and once with the shoes. But these variables or these data points, they're actually connected to the same person. As you can see, this is this person, Jeffrey Kamworor, who ran it without and with the Vaporfly shoes. And so both of these data points are connected to this athlete. So these are not 2 completely independent groups, but rather we can pair each number to a specific number depending on who the athlete was. So these are dependent. And so because of that, we can't use the 2-sample t-test. We're going to use something that works for dependent, the paired t-test. So let's go through our 4-step process. So as our first thing that we wanted to do is we should define our parameter as well as talk about what the hypotheses are that we're going to test. So in this case, our parameter, we're going to be talking about a mean. And notice it's not going to be 2 different means because again, we're not interested in them separately, but really the mean of those differences, the thing that compares them each to each other. And so this is going to be the mean of the differences. So the mean difference between times with and without the shoe. So you'll notice how this is different in the fact that we only have one mean that we're defining. And then we're going to put this little subscript d to represent it's a difference that we're looking at. So one thing about this difference is we should define how are we calculating that difference. Because this makes a difference, right? If we were to do the first number minus the second or the second minus the first, we're going to get different values here. So we need to make sure we define which way we're going to do this. And for the sake of how we have this here, we're just going to do without minus with. So I'll just make a note of that here. So if it's without minus with the shoe, and we're seeing that without is going to be a higher time, a slower time, and with the shoe is going to be a lower time, which is better because you're faster, then we should end up with some positive numbers here, as you're seeing when we subtract. So what is it that we're going to test? Is we're trying to see, does it make a difference? Well, if these numbers were the same, then that difference, just like we would do in a 2-sample test, is we would say, oh, that's equal to 0, right? There is no difference, right? But for our alternative, this is where we have to think about the order in which we're doing this. We're trying to say, if this is effective, if this can actually lower our time by running with the shoes, then when I take a bigger time minus a smaller time, we should end up with a greater than symbol, right? It should be something that's greater than 0 because a bigger minus a smaller is going to be a positive number. So this is our hypotheses that we're going to test. So once again, we already talked about this, but what's the method we're going to use is a paired t-test. And so now let's perform the steps needed to do this. So first, let me just point out, here we have the data, so that's good, right? You're going to see how we can just enter the data into ArtofStat to be able to get that answer. If we don't have the data and we have the summary statistic of the differences, then it would actually be equivalent to a 1-sample t-test. As you can see, even the hypotheses look like a 1-sample t-test. But in this case, since we have the data, great, we don't have to go through all that. Let's run this using ArtofStat. So on ArtofStat, where are we going to go? So this is one's a little interesting, and we're going to actually select the compare two means. Even though we don't have two separate means that we're comparing, we are comparing two quantitative variables. So that's the one we're going to select. And you'll see on top, we have the one that we've been using for the two sample tests. But next to it, we also have this idea of two dependent samples where they're paired. So that's the one we're going to select here. And so from this, we're going to be able to provide our own data, and we can type in all the information that we need. So what I'm going to do is I'm just going to copy and paste the data directly from our list of numbers into this. So our response variable, again, is the marathon time. So it's always good to put something that's reasonable into here. That makes sense. The first group, again, is we're going to do without. The second, we're going to do with, since we're doing without minus with. And now copying these numbers in. And for the second one. And then finally, what we want to do is we want to run the test. So let's make sure we have the correct alternative here. Again, we are looking at a greater than symbol because we're trying to show that the second number is lower than the first, or the first number is higher than the second. And so now we get the results that we're looking for. So one thing that's great, again, about ArtofStat is that it does give us the visual at the same time, where we can kind of see without versus with. When we're running with the shoe, it tends to get a lower time. But there's also a lot of overlap here, so it's hard to say if that's for sure or if this is just due to random variation that we see or variability that we see when people run marathons. However, we do have what we're looking for, which is the test statistic and the p-value. And so that's what we want to report here. So we'll take that information and put that into our step 3. All right, so there we go. So what does this mean for us? So remember, we are trying to compare this at the 0.01 level of significance. So our fourth step is to let's make that conclusion. Well, first thing we notice is that 0.0223, our p-value, is actually greater than 0.01. So we want to make note of that. Since the p-value is greater than 0.01, well, what does that mean for our null hypothesis? If it's greater than this value, even though this is still a small probability, it's still likely when we compare it to the level of significance. We're still likely to see this data under the null hypothesis that there is no difference. So this means we're not going to reject the null hypothesis. So what kind of conclusion are we making then here is, well, we're not rejecting it. We still have pretty strong evidence, but it was not strong enough. So we want to say that we don't have enough evidence to show that running with the vaporflies has a lower marathon time. And there we go, our 4-step process. So while we're on this though, let's think about that last step, the reflecting on our statistical practices, because there's a couple of things that comes to mind just from looking at this right straight away. Is one, how did we collect our data? Because this stuff was just taken from their New York marathons. These were not some kind of randomized trial where we randomized which group they were in or which shoe they got to wear first during which race. So these shoes and these race times came from various years depending on when they wore the shoes and when they didn't wear their shoes. The other thing is we don't know what the conditions were for the marathon. It could have been really hot one year and not so hot the next year. So that could also have a difference on whether their times are faster or slower. So these are things to consider. The other thing that we always want to think about is about our sample size. In this case, we only have a sample size of 6 athletes. And even though we only had such a small sample size, which results in not very much power in our test, we still got a pretty low p-value. So it does make me wonder in terms of additional questions. Is if we did have more people and randomize this, would we be able to then have enough evidence? This is something that might require more additional study.